Hello and welcome to MDX 101, MDX Basics and Structure. This will just be a very simple introduction to MDX. I'll follow it up with a series of videos where I talk more in depth about what MDX can do and show you examples of solving actual business problems with MDX. So let's jump right into it. If you're not familiar with MDX, I'll describe first what that is, and then I'll talk a little bit about why it exists and how it references data inside of a cube. Then I'll talk about a couple of very important concepts. They may not seem terribly important at first, but believe me, you'll find yourself tripped up by them often as you work with MDX, and that's tuples and sets. And I'll talk a little bit about how those work. And finally, we'll look at the structure of a very simple MDX query. I'll show you three variations of it. You'll actually see it running against the cube. And then I'll wrap up this video and come back with some more real-world examples and talk about actually navigating hierarchies and doing a bit more advanced work with MDX. So the first thing, of course, is what is MDX? Well, first of all, it stands for multidimensional expressions, and it's the query language as well as the DDL language for analysis services, for working with multidimensional data. It's similar to SQL in that regard. SQL, you can do a select to query the data. You also have things such as create table, drop table. You have similar things like that with MDX. So it has the data definition part, the DDL portion that can create cubes and dimensions, so forth. And then, of course, it has the query side, which uses a select statement, much like SQL. So MDX will allow us to query multidimensional data, build dimensions, build cubes, also, of course, drop them, alter them. It can create calculated members. Later, in some security videos, you'll see how it is used to define security restrictions, and it does more than that. There are other pieces to it as well. So it's a very rich language, and a lot of people, when they first get into MDX, I think they find it to be extremely confusing. It requires a different way of thinking, and it has a very steep learning curve. It seems very simple at first, and then you really hit a wall where it can be very confusing. But if you stick with it, I think that you'll find that you have a very unique skill. There are not a lot of MDX experts in the world. So, given that it is similar to SQL, why is there a whole new language? Why was it invented? Why not just use SQL? And the problem is that SQL is inherently two-dimensional. It assumes rows and columns. Now, it's true that most of what you end up doing with MDX is shown in a two-dimensional format. It's shown in rows and columns or in a chart or grid that then looks like, or a chart or some kind of graph, I should say, that is still fed off of two-dimensional data. But cubes are inherently multidimensional, of course. So with SQL, you have just this intersection of a row and column, and there's some cell with data there. So it's very much two-dimensional and tabular in nature. But cubes are multidimensional. They can have more than just rows and columns. They can have 3, 10, 30, 100 dimensions. Okay, they can be very complex. So the data that comes back can actually be returned in more than just 2 dimensions. So rather than a result set coming back, you have what's called a cell set. And this cell set may well contain many dimensions in it, many more than 2. Now, again, typically you will flatten those cell sets into 2 dimensions in order to display them. But it still may be constructed of more than 2 dimensions. You may just format the data in a 2-dimensional format in order to display it. So when you bring back a cell set, you have potentially many dimensions in it, and the intersection of all of those dimensions is a particular value, a cell. And measures, in a sense, get treated like a dimension in that if you wanted the intersection of product and time and customer, well, there are multiple measures there. There's unit sales, there's dollar sales, there's a number of items returned, and so on. So the measures in that sense become just another dimension on your cell set. So here is a cube, and this is obviously a very simple cube with 3 dimensions. And I'm going to assume for a moment that we're just interested in sales, and that's what you have here. So you'll notice the first example is 2002 sales for meat in California. Well, the way to look at this, of course, is very simple. 2002 is the third column, and California is the top row. So if you take this 2002 slice of the cube and then the California slice of the cube, you're now in this one piece and the top of it, and we're interested in meat, so it's actually this cell right here that I'm moving the cursor over. Okay, so that's where the value would be found. It is the intersection of those three dimensions. In a similar fashion, here in blue, the 2001 sales for dairy in Oregon. Again, 2001 is the second slice out of the cube, the second column. Oregon is the third row, going from the top, of course. And so 2001 is here, and then dairy is this whole front slice. So we're in this cell in this particular case in order to get that value. So if you think about when you're constructing a query, what this is going to look like and how you want to get the intersection, it's really fairly simple at a conceptual level. So I want to talk a little bit about dimensions and hierarchies. Each attribute in Analysis Services 2005 and 2008, each attribute in a dimension is basically treated as its own hierarchy. In fact, they are called attribute hierarchies. Now, attributes by themselves are usually not terribly exciting. It is an all level and then the detail for that particular attribute. So, for example, if you had product category, it's simply all and then 3 or 4 or 5 or 10 or however many product categories you have. That can be a bit dangerous, of course, when you are at a low level of detail. So, for example, let's say that you're at the base product level and you have 1 million products. Then you have the all level, and someone drags that over in a query, drops it to, let's say, in Excel to look at. Suddenly it's going to sit there and have to fill up 1 million items in order for them to see it. So you can, of course, use these hierarchies. You can use them in queries any way you want. But typically, you'll build multi-level hierarchies out of these attributes. And if you use an attribute in a multi-level hierarchy, you will typically then hide it as a standalone attribute from end users. You can still reference it in MDX, but they won't be able to see it in their query tools. So here's an example. A customer's hierarchy might include countries, states, cities, and then the actual customers. So some terminology for you here if you're not too familiar with this. All the customers in the customer dimension, all reside in the customer dimension in the customer's hierarchy, meaning all of these attributes reside in that customer dimension. So they're in the customer dimension, and then the hierarchy that is built just is called customers, just as an example. Each grouping is called a level. In other words, countries, that's a level. States is a level. Cities is a level. And then the individual customers, that's a level. And a value within a level is called a member. So in the countries level, there might be a member Canada and a member United Kingdom. At the states or provinces level, again, you have members at that. If it was the United States, you would have, for example, California as one of the members, New York as one of the members, and so forth. So just be aware of these terms, level and member, because that will get referenced as we look at MDX and I talk about adding different items to the query. Now, one of the things that you'll see as I start working with this is you'll see a lot of square brackets and sometimes you'll see ampersands. Square brackets are required in a couple of cases. If it's a reserved word, or more importantly and more commonly, if there is a space in the name. So here you'll see I said dim name, so that's the name of the dimension, and I put a space in there, so I had to put it in square brackets. Then the name of the hierarchy that I'm referencing, no space there, so I didn't have to use square brackets. Then the level name, again a space, so square brackets around that, and then the individual member in which I'm interested. Now, I don't always do this, but a good recommendation is always put the thing in square brackets anyway, whether there's a space in it or not. It's just kind of a convention people have gotten into the habit of doing. So again, not required, but just kind of a convention. Now the ampersand, on the other hand, is required when you're using the member key instead of the member name. Now, if you're not familiar with that, go back and watch the videos on dimensions. But the member key, of course, is the actual underlying key. Sometimes, well, often that's just an integer value, so it's not terribly exciting. The member name, of course, is what's displayed to the end user. So here are two examples: date dot ampersand 2002 in square brackets compared to date dot cy space 2002 in square brackets. Because 2002 is the actual underlying key, it has the ampersand in front of it. cy 2002 is the member name. It's just cy and a space were concatenated on the front of the actual value. That's what gets displayed. You'll notice underneath that there's an example reseller dot ampersand warehouse, or underneath it, again, it's just reseller, but now resellers in square brackets. It wasn't before. Those are they're equivalent. Either one will work just fine. Now I want to talk about tuples for a moment. Some people call these tuples. Both pronunciations are correct, but tuples is the preferred. A tuple represents a single member from one or more dimensions. In other words, a tuple defines a single cell. For example, if I said, show me the value for 2002, let's pick a measure, say it's for sales. Okay, sales for 2002. 2002 is a single value that represents a cell. It is the year 2002, but the sales there would be for all customers, all product, all promotions, etc., etc., etc. So all the other dimensions in the background are in play. It's just that by default they're at the all level. So a tuple could be as simple as just the date. You see that as the first example. Date ampersand 2002, or below it just cy 2002. Now you might say, well, why doesn't that say date dot cy 2002? Well, I'll talk about that in just a moment as well. But basically, MDX will search for that name. If you don't tell it what dimension or what hierarchy it's in, it will search until it finds it. Of course, if it doesn't find it, then it throws an error. But if it does exist, it will search until it finds it. Obviously not preferred. It is much slower to do that. You should always reference these things when you have the chance. The third example there, this is more common for a tuple. This again is a single member from, in this case, two dimensions, Atlanta and cy 2002. So the first value, Atlanta, is from a customer's or a geography dimension, depending on how this is set up. And of course the second member there is from the time dimension. The fourth example here, the first value, Atlanta, again from a customer's or a geography dimension. The second member there is from the time dimension. The third member is from the product dimension. Now, bikes happens to be at a very high level. You could put lower level items in there as well. But again, these are just examples of a tuple. And this will become very important later, because this is really how you'll end up referencing a single cell. Again, assume for a moment I'm talking about a sales measure. It's clear that from that last example I would be getting the sales in the city of Atlanta for the entire year of 2002 for only bikes. So again, that's the intersection of those dimensions, and I would get it would result in a single cell for me. Now sets, on the other hand, are multiple members from the same dimension, or they can also be a group of multiple cells, and I'll show you that, basically a set of multiple tuples. I'll show you that in just a moment here in the examples. Now sets can also result from a number of MDX functions, and I have a couple of examples of those below, even though we haven't talked about them yet, but you'll see what that means. When you make a set, it has to be inside of curly braces. So you see what those look like there on the slide. And in the examples, you can see bikes, clothing enclosed in curly braces. So it's not a tuple, because that's multiple members from the same dimension. Both of those members are from the product dimension. Same thing with the second example. Calendar year 2002, comma, calendar year 2003. They're in square brackets because they have a space, and they are enclosed in curly braces. Now take a look at the third example. I have two tuples combined into a set. So because they're tuples, they are both enclosed in parentheses. And so one of the tuples is bikes in Canada. The second tuple is clothing in the United Kingdom. Together they make a set. So what I would be doing here, again, let's assume for a moment I'm looking at sales. I would find the sales for bikes in Canada and the sales for clothing in the United Kingdom. It wouldn't add them together. It would return two cells, but that's okay. That's what my set represents here. The fourth example here uses an MDX function called children. So calendar year 2002 dot children is going to return something to me. Now, it so happens in this case that calendar year 2002 is part of a calendar hierarchy inside the time dimension. It's not just the year attribute, it is the year level of a hierarchy. And the way this hierarchy is constructed in the AdventureWorks database is it goes from year to semester or half year. So children is one level below that. So what I would be getting are the items in one level below calendar year 2002. Well, since it's semester level, I would get first half of 2002 and second half of 2002. So that is the way that works. And again, those are two items, first half and second half, both of 2002. That's two items from the same dimension, so it's a set. And finally, the last example uses another MDX function, top count, and I'm saying get me the children of road bikes. Get me 3 of them based on their internet sales amount. So what I'm doing basically is taking the top count again, so I'm taking the top 3 road bike types, whatever is below road bikes in this particular hierarchy. It's the actual model numbers. I'm getting the top 3 based on the internet sales amount. So again, you'll see a lot more of these functions. I'll talk more about children, and there's a parent, and there's a siblings, and a cousin, and there are all kinds of other member functions that I can use. But you will see these in future videos. Just again, the purpose of this is to think about this being a set. So what does a basic MDX query look like? Well, it starts off looking a lot like SQL. It's not SQL, and there are a couple things I'll talk about here. And there's more to it than this. There are other clauses that you can add, of course, just like SQL. But basically, the select clause selects sets on up to n axes. So the only thing that you can put on an axis is a set. So notice select set 1 on columns, set 2 on rows. And I can have any number of axes. There may be some limit. I don't know what it is. Believe me, it would be bigger than any query you'd ever want to structure. The from clause then is just the name of the cube. So that's fairly simple, much like, again, a SQL statement. Then the where criteria will filter or slice the data. It's similar to a SQL where clause, but there are some major differences, and I'll show you those in the next video, one in particular. But just be aware of this is the basic structure of what this looks like. And before I jump in and show you a couple of examples, just be aware that because you can have multiple number of axes, you have to think of how you want to reference them again, since there can be basically an unlimited number. So axes can be either named or numbered. Now the first 5 axes have names. You saw in the previous query columns and rows. You also have pages, sections, and chapters. So the first 5 have names. But what if you need 6? Well, you can also use numbers. So notice that the numbers do start at 0, of course. Notice these bottom 3 queries. These are all equivalent queries. So select set 1 on columns, comma, set 2 on rows from a cube. Select set 1 on 0, comma, set 2 on 1 from the cube. Or select set 1 on axis sub 0, comma, set 2 on axis sub 1. I've never actually seen anyone use the axis sub number syntax. They just use the shorter syntax of on 0 and on 1 and on 2 and on 3 and so forth. And that's fine. So Let me jump into Analysis Services, into SQL Server Management Studio, and run a few simple queries and kind of let you see what that looks like. So here I am in SQL Server Management Studio, and I've just connected to my local server. And what I'll do at this point is create a new query. And notice I am pointing to the AdventureWorks cube. I could pick different cubes in this database. And of course I could have picked a different database up here. But at this point I'll close the Object Explorer to give myself some more room. And I'll show you that even a very simple query here that is valid. So what I'll do is I will type a query that might not look like it would be valid at first. I'm actually just going to put the curly braces as blank. So I'll put on 0, and I'll use the shortest syntax I can to show you what this looks like. And I'll put these on 1, and I'll simply give it a from clause. And at this point, you'll notice that, of course, in square brackets, since there's a space, this is actually a valid query. It looks really strange, but it is in fact a valid query. So now if I run this query, you'll notice that nothing comes back, but I didn't get an error message either. And if I look at messages, in fact it says that a cell set consists of 0 rows and 0 columns. So that theoretically is a correct query. So let me make it slightly more interesting perhaps. And so on 1, I'm just going to return bikes. So let me execute this. Again, nothing's still on the rows here, and bikes come back, but I don't actually get a value. Well, that's okay. So let me put a date in here, and the date that I'm going to put in here will be a value for 2002. Now I'm going to paste this in. Notice that it has an ampersand in front of it, so I am using the key. Now again, I will execute this query, and notice I do in fact get a result set back. Now you might ask yourself several questions at this point. First of all, what is bikes? Well, bikes is actually a member, but notice I have not referenced the dimension or any particular hierarchy in it. Again, it's going to search and look for a member with just that unique name, bikes. Obviously this is not the most efficient way of doing it, because it does have to do this search. I'll show you a quick example by putting in something that doesn't exist, which is cars. And now when I execute this, you'll notice it's taking a lot longer. And this is a small data set, so you might say, well, it's only 2 seconds. Yeah, but before, when it was bikes, it didn't take anywhere near that long. And of course, it's complaining that cars cannot be found. So I will go back to bikes at this point. Sorry for that. And when I execute this, of course, you'll notice it comes back, it says 1 second, but clearly it comes back very, very quickly. Now this is also a tuple in effect, so I could put it inside of parentheses here. Not necessarily required at this point. This will continue to operate just fine. Also, you might say, well, okay, what is bikes? Well, bikes is a member at a particular level. So it's just one cell. I'm getting that member and getting back the results for this. Date 2002. Okay, at least now I know some dimension. Notice I have a dimension over here in my metadata tab called date. And since I'm using the key value, the key makes it unique, so that is the particular value I'm pulling back there. Now again, I'm using 0 and 1. I could put columns and rows here, and it would work just fine. So you see here I've just switched them to columns and rows, and we'll run it, of course, and it executes just fine. The order of columns and rows doesn't really matter. I could replace it here, put columns down here, put rows up here. I say it doesn't matter. Of course, it's going to matter to the query, but or at least the results set how it's going to look. Obviously down here at the bottom it's going to switch bikes and the year, but it doesn't matter if I list rows or columns first when I construct my query. Either one works fine. Now, another question you might have is, well, what in the world is this measure? Nowhere in the query have I specified what that measure should be. So I'll talk about that in the next video. So again, just a very simple query. I've made a couple of changes to it, added some things, but it works just fine. I did show you before that there was a .children. I'll just show you that quickly. So right now I have bikes. I will add a .children to this, and you will notice when I do this that it will continue to appear where I have it, but notice what happens to the bikes member. It breaks down to that next level. So bikes is somewhere in a hierarchy, and it has broken it down into, that's actually a product category, and now it's broken it down into the product subcategories under that. So again, just a very simple MDX query, but we'll be building on this whole concept of MDX moving forward. So in summary, MDX is the language for querying cubes and much more. It's for creating cubes and dimensions, it's for creating calculated measures, dealing with security, and so on. The whole reason that MDX exists, though, is to be able to navigate multidimensional objects, construct queries, construct security constraints that are multidimensional in nature. And remember, when you're doing a query, when you're doing a select, any axes that you build, or any axis, the axes that you build are going to need sets on them. And that becomes very confusing because there are some functions that return a tuple and some that return a set. And sometimes you're only returning one member, but so it's let's say you're running a function that's going to return a tuple, but you want to put it on the rows or columns, and so you have to force it to be a set, and there are some things that get a little confusing there. But again, just a quick introduction to this. The next video I'll get into some more navigation, moving up and down and moving across time to look at comparable values and so on.